An electron falls from rest through a vertical distance h in a uniform and vertically upward directed electric field E. The direction of electric field is now reversed, keeping its magnitude same. A proton allowed to fall from rest through the same vertical distance h. The time of fall of electron in comparison to the time of fall of proton is. Four options are given. Let us go for the answer. Here there is an electric field E vector which is vertically upward in direction. Remember that there is a positive plate at the bottom and there is a negative plate at the top. Here at the bottom you have a positive plate, right? And on the top you have a negative plate which produces this uniform vertically upward electric field. Now an electron is being placed, it is attracted towards the downward direction because of the positive plate. So the electron moves in the direction opposite to electric field. Good. There are two forces. The one is the weight of the electron, which is always downward, equals MEG. Another force is due to the electric field Fe equals Q times E. Here the Q is replaced by small e, the charge of the electron. Good. The distance is h and the initial velocity is u. Let us go for the second part of the same question. Now the electric field is reversed. What is the meaning of this? On the top we have a positive plate. On the top we have a positive plate and at the bottom we have a negative plate. This is the positive plate and here you have a negative plate. Now the proton is being placed plus E, right? It is attracted by the negative plate which is at the bottom. What you understand? This proton moves along the electric field. Positive charge moves along the electric field. Negative charge moves against the electric field. That's what you need to understand. Good. What are the forces? Its weight of the proton is always downwards, mpg, and the electric force Fe equals Q times E. Here Q is replaced by the positive charge plus E. The same vertical distance, the same initial velocity u equals 0. Good. Now, let me take the charge as Q. Whether it is an electron or proton, it always goes down, right? So, as u equals 0 and h will be equals half at square, t equals root of 2h by a. Let us write this t equal root of 2h by a. Here for electron the acceleration is different and for proton its acceleration is different because of their different mass. The mass decides this acceleration. Good. For a charge q in an electric field experiences an electric force q times E along with its weight mg. So in both the cases, both the forces are acting in the same vertically downward direction. So a general equation is drawn. F equals Fe, that is force due to electric field, plus weight. It's equal to the total force. So ma equals q times E plus mg. So acceleration equals q times E divided by m plus g. Let us write this here. Good. So we have to rewrite this equation for electron and proton separately. For an electron, acceleration of electron equals E times capital E divided by mass of the electron plus acceleration due to gravity g. So let us use the time equation, time of fall equation. Te equals root of 2h divided by, in the place of acceleration, let us write acceleration of the electron. Acceleration of the electron. Here E divided by me plus g. Good. Let us go for proton. The acceleration of proton equals E times E. There is no change in the magnitude of the charge, but there is a change in mass of the two charges. Here it is mass of the proton plus g. So time of fall of proton equals root of 2h by E divided by mp plus g. Right? We know very well that the mass of the proton is much greater than the mass of the electron. Mass of the proton is 1836 times the mass of the electron. Therefore, the time of fall of electron is smaller than the time of fall of proton. Thank you, children.